This is a talk about TV development, and well, there are some empty seats, so I assume this is not totally mainstream, but thank you for you being here. And I assume the people who are here are somewhat at least interested in TV development with Flutter. So this is what the talk is about. Actually, we're the two of us. Daniel will have to wait a bit until I give you all the context and the boring details about the project and stuff. And I'm the product owner of at Deutsche Welle. Daniel is architect and developer on the team. And this is what we are going to talk about. So as I said, I give you a bit about the context of the project, some facts about Deutsche Welle, the questions we had to answer in when we started the project, the what, the why, the who. Actually, that's very important in a big organization, and actually how we got the project rolling. Maybe that's boring or not, but it's very important for such a project to get off the ground. Of course, you want to see the app. I show you the user experience designs that we had, and then I give you a walkthrough through the app. And I must admit, I didn't want to do it live, so I have a video and I give the audio track on top of that. And then Daniel takes over and gives you some glimpses into the challenges and the code that we have. So let's start. Some, well, more or less fun facts about Deutsche Welle. We are an international broadcaster, so we have 32 languages. We have programs delivered all over the world. We are funded by the German government, but we are still sort of independent of government influence. And this is really taken care of by a law, Deutsche Welle Act. And so I think we do good journalism really without influence from the government. We are a member in larger bodies, Arbeitsgesellschaft der Rundfunkanstalten Deutschlands, ARD, and EBU is European Broadcasting Union. They do the European Song Contest every year, so maybe you know them. And as I said, we have a global program, 32 languages, the easy ones, the European ones, but the harder ones with RTL, right to left notations, different alphabets. We don't have all of them in our app. We start with English, Spanish, and later Arabic. It's not in there yet, and German, of course. As Deutsche Welle, we also have not just the journalism, but we also do sort of have like an educational aspect, the International Media Development Center, and we do German language courses as well. And the thing on the right is something else we do in our small team. We don't just do the TV app, but we do also have a mobile news app, which unfortunately is not yet implemented in Flutter, but maybe at some point. Okay, that's the institution, and now a bit more focused onto the actual project. We already do have TV apps as Deutsche Welle. We started development in 2016. We have very separate code bases, not just from the technology point of view, but also from the look and feel. The screenshots here, the topmost one is the oldest one for Samsung and LG televisions. It has this vertical navigation. On the right is the current Apple TV app, and on the left is a Roku app. And all of them use different technologies, which is necessary to some extent on the TV market, because as opposed to the mobile market, which just has these two major players, the TV market is rather fragmented, and you need to have all these different technologies to address individual sort of market and platforms. Okay, so you know a bit about us, about the project, and now really what are the goals of the project? We come from a TV satellite broadcasting background. So we have live programs. We also have large satellite dishes on our headquarters, and this is what we're coming from. But obviously, the world for some 10-ish years now has moved on away from live streaming to on-demand video as well as audio. And of course, we do this for a long time, but there is still some transformation internally going on. And this new project should really sort of move our focus towards on-demand programming. As I said, we already do have TV apps, but they're all different code bases, and we want to consolidate our offerings. And the last really important aspect is in the past, we sort of did software development lifecycle, the sort of waterfall way. Large concept phase initially, some development, thrown it over the fence, and then left it die slowly. We want to do better for the new product and start small with an MVP and then incrementally add features. And so there's also some process, organizational re-engineering going on for this project as well. I have a large slide with just all the motivations that play into this project. I don't want to go into all of these aspects, but there are many aspects why we actually do this. So there are lots and lots of people who are involved in the project, and all have their agendas and all want to take part in the project. These are some of the departments that I on a regular basis talk to as a product owner. So it's a big undertaking. This is all that I want to transport with these two slides. It's not just building a new app. So we have started, we got the budget. We have a goal, we have good stakeholder management in place. But we didn't quite start immediately, but we rather did some good amount of analysis. We looked at the market, we looked at the competitors, different aspects of them, so their portfolios, their user experience, their technologies, how they position their brands. We looked at the sort of fragmented TV market and looked what was possible on the different platforms. And of course, we had our own offerings in place, so there was something we could look at as well. And one learning from this sort of extensive analysis that we did was that these are the platforms that we have to target. HTML5, this is Samsung, Tyson, LG WebOS, Hisense, and a myriad of other players on the market who are all more or less based on HTML. Then there is this sort of the Android TV area with Fire TV as well. So Amazon has Android TV boxes. They're moving away from it, but it's still Android TV. And Roku, which is a bit of a pain, but still quite important because it's very popular in the US. And last year they launched in Germany as well. So all of these players give us sort of 80% of the market. Apple TV is not on this list, but well, we have an old Apple TV app, and at some point we want to port to Apple TV. So on that, we learned on this conference that it may be possible. So the project is set. We had all the analysis in place. Now we need technology, and the first impulse really was just, well, TV app. How difficult can it be? We just buy the thing, and that was really my preference initially. But when you look at this time frame, just buying the buy scenario would have given us a rather late sort of time to market. The precondition was that we have apps in-house and we have expertise in-house. We also had access to external developers already through contracts we had in place. But if we wanted to buy a solution, a ready-made solution for TV, we would have to do a public tender. And because it's such a big project, it would have taken rather long. Like we estimated 9 months would it take to get out the tenders, have all the applicants return their proposals. So in essence, that would have meant 9 months delay and only be able to start developing in the beginning of this year. And then we still would have to adapt the sort of bought solutions to our internal systems, and only maybe in autumn this year would be able to start actually incremental development. So that was one approach, one scenario, with, well, the risk of external software. With tenders, you have to do it again after 4 years. So that was another risk that we would have to face. And one scenario, very fiercely debated internally, but the make scenario was still there. And again, same precondition. We have the existing apps. We have development resources in-house. We know how to build TV apps. Well, we're here at Fluttercon, so you know the outcome of this decision. Ultimately, we decided to build ourselves. We could start early last year, get an MVP, a minimal viable product out of the door. We didn't make it quite by the end of the year. Daniel will give you some details on why that was. But still, we managed to launch by the beginning of this year, and then we are already in the phase of adding incremental improvements both to the feature set as well as to the platforms that we are targeting. So in sum, these are sort of the argumentations pro and con, make versus buy. Ultimately, the time to market was the key argument that made us decide for actually building our own solution. Okay. So we decided to build the thing, but how? You already know where we ended. We're at Fluttercon, so we decided on Flutter, but that was not an easy decision process. Two of the suggestions that we had from early talks to commercial vendors was strongly in direction of React Native. We made our own experiments, and we're not very much, it was not a pleasant experience. There were two other web-based candidates. Vechtel is a compiler-based sort of component framework in JavaScript that looked quite nice because compiler-based means that it can cope with the low performance we were expecting from TV platforms. And Lightning.js, you have probably never heard of it, but it's a framework by Metrological, a company that does sort of white label TV solutions, and it's really catered towards TV development. So that were the candidates. One thing that made the decision a bit easier was that sometime last year Samsung announced official support for Flutter on their Tizen platform, and so we had the most important platform for us supporting Flutter natively. Flutter was in our team the favorite solution because we thought, as I told you, we have the news app at the moment Kotlin and Swift, but at some point we might find a common technology for both the news app as well as the TV app. So that was really a favorite of our development team. But there were other criteria, obviously. We have to sort of get the technical criteria right. We have to target all the platforms. Developers have to be happy, of course, but we still have to ramp up a new technology. So we have to get know-how internally. And it also needs to have sort of a good fit strategically. We have back-end software in Java, in React and JavaScript. We do have Kotlin and Swift development. And the technology we were about to choose should sort of carry us forward for some years at least. So we made this matrix, big spreadsheet with all the criteria that did some scientific calculations. And in the end, there was some figures coming out that would Flutter a healthy sort of first, and the other ones sort of falling a bit behind. So Flutter it was, and this is why we are here. And we've already launched our first platform, so it somewhat was the right decision. And I want to now show you what we actually built with it. This was the initial idea that, we had long discussions, obviously, what was the minimal expected feature set for a TV platform in 2024 with Netflix and Prime Video and Apple TV all having these huge sets of features. And now we, as a latecomer, well, the expectation was we do have to have a minimum set. Without that, users would just not accept our app. So this was the initial sort of idea what we have to build. So obviously home stream, live streams should be in there. There should be featured content. All our shows should be there. Also personalization features. Search was a no-brainer. It should be in there. And some settings, privacy policy and stuff like that. But we wanted to establish iterative development. So this is still a bit big of a sort of scope. And after some discussions, we decided that's not what we needed to launch with. So we chopped out bits and we ended up with this sort of minimal launch scope that we then actually built and launched on LG a month ago. So it's the start page. It has live streams with live players. It has a show page, shows with episodes in them. Obviously, video detail pages and video player in some settings. You can choose the language. You have some features for binging episodes, but it's still a very minimal set. And as you can assume from that, we're not finished with adding features. So search is missing, some regional focus is missing, some topical focuses are still missing, but it's a scope where you can launch a TV app. And I just want to show you, well, these are the use cases that you can do with this, but I want to show you the app by walking through a video, and I try to do the audio track on top of it. So actually, so this is the home page. You have this this highlight area on top of that, and then rows of content as expected in a TV app. So when the highlight area, then underneath that there is this continue watching area. I now switched on one of the videos. You have a player. You can skip forward and backward. Once you reach the end, if you don't do anything, you can just binge through videos by automatically choosing sort of from the similar videos either or from the episodes in a show. So this is the end of the first video, and now comes the autoplay feature. So there's a little timer in there, and it will continue automatically. No surprises here. That's you'll have to expect that if you have used any of the streaming apps. So I'm in the next video now. Again, same player. Everything here, by the way, is obviously controlled with a remote control, so you don't have touch control. You have the D-pad where you have the directional keys. So again, in another video here. And there's the continue watching. So anytime you start watching a video, you haven't finished watching it, you get this entry in a row where you can just continue it at the point where you left off. So that's a nice thing to keep users in the app actually, and help them restart once they're left off somewhere. This is the row of shows, sorry. Shows is a bit special. We have individual short videos, but we do also have this formats or shows, which have episodes. Some of them have preview pictures, others don't. A show has a detail page with some textual information on them. You can play an episode, choose next episodes, again, the same player with the same features. Similar videos for each of them. Okay, so this is video content on the start page, shows, and now I open the main navigation. There is lives and a page with shows. Now I go to the live streams. It starts with the English live stream. There is some program information, electronic program guide underneath it. And from the streams page, you can reach the other streams. So in this case, we already have the English and the Spanish one. Again, Spanish live stream with program information. hopefully something people would expect from such an application. Then there is the show page with all our shows, a grid of shows. At some future point, we'll have some intermediate headlines there, but at the moment, it's just a grid of shows, specific for each language. So the English language has English shows. When I later switched to Spanish, it's a completely different world of content. And Spanish shows, Arabic, again, different world of content. Now I do switch the language first to German. All the labels and headlines are in German then, but the content has changed as well. So we do not have translated content, but we really have different editorial teams who do different, for each language, do completely different programs. So when I switch to Spanish, again, all the labeling, all the UX writing is in Spanish, but all the content is in Spanish as well. This is a feature for the autoplay feature that you've already seen. Some legal and textual information can be navigated with a D-pad. And that's about it. That's the app that we've built and launched a month ago, built in Flutter on LG televisions. So, thank you. So that maybe or maybe not was the boring part. And now I hand over to Daniel, and he'll give you some insight on the challenges and the code base.
Yeah. First of all, welcome from my side, and I will talk a little bit about the technical part of the presentation, which is how to build the app for WebOS with Flutter. And we are starting completely from scratch, which means we are creating a Flutter project, of course, with web support. And we can do this by the command flutter create and the project name. And the result of that looks like this. We've got the familiar folder structure with our web folder, containing an index.html file, test folder, lib folder, and some other folders. And to build a WebOS app, we need to add some additional files, some configuration, some external libraries, and we need to make some changes to the index.html file. And we're starting by adding an app.info.json. This file can be compared with an info plist or with an Android manifest file. It contains metadata such as the app ID, the type, supported orientation, theming, and so on, some values which are needed to configure an app. And another file which we need to add is a JavaScript file coming from LG, which is called webostv.js, which provides some native methods. For example, if we want to implement the platform back, if we want to get device info, the platform, OS version, and infos like this. And last but not least, we've got an additional external library also coming from LG. This one is called webostv-dev.js, but it's not a dev dependency. It's named dev, but it's also used for release builds. This is a little bit confusing by LG. They've just named this dependency dev because it's the newer dependency and they don't want to name it dependency 2, for example. And it provides even more native WebOS methods like the launch parameters, if we want to get the LG unique device ID and so on. And after we've added all these files, the app info and the WebOS TV libraries, we've got this folder structure. I've created a lib folder where the WebOS libraries are part of. And I've also added another library which is called HLS for live streams or for streaming. And I've added an app info file. And here's an example of our app info file we are using for WebOS, for our WebOS project. And as you can see here, we've defined the name, a short name, a background color, and some other values. The next part is we need to make some changes to the index.html file. The first one, of course, we've added external libraries and we need to reference them. This can be done in this way. And the special part here is that we are adding them with a relative path. Normally you are using absolute paths here, but LG or WebOS works differently because it's more like an app than a web page. And because of that, we are using a relative path. I'm coming to that later in my presentation. After we've added all the external libraries, we can also use some native functions. Depends on our context, which function we need. Another thing we need to do to the index HTML is we need to change the hyperreference to a relative path. By default, Flutter is using a parameter for this called Flutter_base_href, which can be defined via the Flutter build command. They can set the parameter of that href once. In our case, we need to do this manually and to change it to a relative path because according to the Flutter documentation, we can only use absolute paths here, which looks like this. And here it is mentioned that the value has to start and end with a slash, and the relative path doesn't do this. And so we need to change this as well. Another adjustment we need to do through the index.html file is we need to add an interceptor for the fetch API request to load local files via XML HTTP request. Local files can't be loaded via fetch API. If we are trying to do this, we are getting a URL scheme file is not supported error. And to prevent this, we need to create a condition and check if the URL starts with HTTP. And if this is the case, we are using the fetch API. But if we are trying to load local files, we need to intercept this fetch method with XML HTTP request. Here's a little example of that, which is more or less like a normal JavaScript intercept method. And if you're interested in this topic, I've also added 2 links below, one to a GitHub issue and one to the pull request where Flutter has changed to the fetch API from XML HTTP request, which was done from Flutter 3.7 to 3.10. And after we've done all the changes to the index HTML, we've got a Flutter app which should run on WebOS. But WebOS is a smart TV, or we're trying to implement a smart TV app. So we need to also fulfill some requirements. And the first one, of course, is we need to add support for 2D or spatial navigation. And we need to ensure that one widget is always in focus, because with a TV is controlled via remote control, and we don't have a touch functionality here. And this is more or less a default Flutter function which you can use. We have changed that a little bit because we are not so happy with the default version of the reading order traversal policy Flutter is using, because they are using a weighted function to find the next focusable widget. And we want to change that. And because of that, we have created some custom method for that. And here's a little example with a video which is currently in focus. The name is "Should Buying Sex Be a Crime?", which is, by the way, completely random. And if the user has focused this widget, he can navigate to the next or previous video by D-pad, or can go up or down also with the D-pad keys. Another requirement which we need to fulfill is we need to support WebOS media keys on a conventional remote control. This wasn't that easy because the key code which we need to get to map to distinguish between different media keys is not part of the key event. And because of that, we haven't used the key event, which is currently used in Flutter versions. We are using the war key event, which is legacy API, I think, since Flutter version 3.19. And to get the key code out of the war key event, we need to check if the key event comes from a web platform, which is the case if we are trying to implement a WebOS application. And we need to map that key event to a war key event data web. If we're not doing this, we're getting a key up event, which can look like this. And as you can see, we've got a key label of unidentified. We've got a default key ID. Debug name is null. And all the other values are also null. So we can't use that to distinguish between the different media keys. And because of that, we're doing that mapping, which can, for example, look like this. We're getting some kind of key event, and we are checking if the key event is a war key event down, and if it contains war key event data web to get the key code and to distinguish between the different media keys, which are coming from a G. Okay. So we are done with some requirements. I've only mentioned a few of them. There are a lot more, but I focused on some of the most important or most difficult requirements we have to fulfill. And after we've done that, we've uploaded, we've created an IPK file, and we've uploaded that artifact to LG. And we've waited for the result of the QA process. And this slide is called first iteration. So I think you can expect what the result of the QA process was. Our app was rejected due to poor performance and out of memory crashes. And by the way, I think I should mention that an LG TV has the performance of a toaster. So it wasn't that easy to run a Flutter app on an LG TV. And so we've started to make some performance improvements. And we started by reducing the size of the video teaser images by a factor of 10. We've removed all the animations, including image loading animations, page transitions, fade-in animations, fade-out animations. We removed everything because an animation doesn't look good if you've got only a few FPS. Another thing we've done is we've implemented lazy loading for all vertical and horizontal lists, which means on the homepage, you are only the widgets you're currently seeing are loaded, which means the rows above and below the current rows are not loaded, and the video teasers on the left and on the right of the video row you're currently in are also not loaded or not built. And we've also reduced the build calls even more by creating more constant widgets. And all of these improvements are more or less like the default Flutter performance improvements you're doing if the performance isn't okay in the app. Another special thing we've done is we've also added deferred loading, which I think is only available for web and for Android. I think it's not available for iOS. This means instead of compiling our whole code into one JavaScript file, we are compiling it to multiple files, and these files are only loaded if the user is accessing the feature the code is needed for. For example, the video details page is compiled into one extra JavaScript file, and this file is only loaded if the user goes to a video details page. And by doing that, we have reduced the size of the JavaScript file, which is loaded at the start of the app. And again, we've uploaded the artifact to LG and waited for the result of the QA process. And this slide is also called first iteration. So there might be a second iteration. And the result is we are still rejected due to an out-of-memory crash. And at this point, things are becoming interesting. Because we've checked the memory usage of our app with Flutter DevTools, with the Chrome DevTools, with Beanvisor, which is the LG performance monitoring and diagnostic tool. And we've got no memory leaks and a maximum memory consumption of 150 megabytes, which is totally fine. And we've also asked LG, hey, how much memory is okay for our app? And they mentioned that everything up to 250 megabytes should be perfectly fine without any crash. And here's a diagram of or graph of the Beanvisor performance measurement or the memory measurement. And as you can see, we're not using more than 140 megabyte at all at any time. So the question is, where does the 100 megabyte plus of memory usage come from that causes our app to crash? And we've took a closer look to the Beanvisor tool, and we've discovered that the Smart TV's system memory had some huge spikes, coming from 827 megabyte up to 1,133 megabyte in system memory usage, which looks like this. And this is about 300 megabyte of system memory usage when we are starting our app. And yeah, at this point, we've done some reverse engineering. So why does our app need so much memory usage? Because our app itself only needs 150 megabytes. So where are the 300 megabyte of system memory usage are coming from? And we've done reverse engineering for that. We've just removed more or less all our features from our app and checked the memory usage, and then added one feature after the other to our app and checked if the memory usage has changed. And we've discovered some issues which are using that memory usage. One of them is that some of the images were still in full HD resolution, which is completely fine. We've changed the resolution, and we've reduced the system memory usage by 15 megabytes. Another issue is that we are using a Go router and we have used the shell route. And by doing that, we've increased the memory usage somehow by 50 up to 100 megabyte of memory. We don't know why. It is what it is. And we've removed the shell route and replaced it with a route, and we've changed the way that raw navigation is structured. Another thing is we have used a gradient widget. And by doing that, the system memory has spikes of 50 to 100 megabyte. So we've removed the gradient widget and replaced it with a constant gradient image. And another issue was we have used SVG icons or SVG images in our app, and we've also merged them into a font instead of SVG images directly. And after doing that, we've reduced or removed nearly all of the system memory spikes. As you can see here, the graph, the top graph shows the system memory before our improvements, and the second graph shows the system memory after all of our improvements. And as you can see here, the spikes are gone. And after all this time, we've again uploaded an artifact to LG. We've waited for their QR process, and they have accepted our app finally. And here's a QR code you can scan to get access to the LG store, and there you can see our app.
Yeah, thank you, guys. So as you can see, that was quite an exciting journey. So nobody should say that software development is somewhat boring. And well, I do the boring parts, but they have some excitement in there. So I don't want to bore you with much more details. Just some idea. I already mentioned that we started some iterative process now, and well, this is the image flying cars. There we want to want to be at some point. Obviously, our sort of experts, UX experts, said we should start with a flying car. Otherwise, so our users would just run away. But they don't. We have an app now on LG. We continue with more platforms. So Samsung Tyson is in the making. This is the more important platform, I should say, and the one that actually officially supports Flutter. So we hope it will be a bit easier. And then Roku TV, Android TV, and Roku TV and Apple TV still is a bit of an unknown. We learned on Fluttercon that Apple TV might be a possibility by changing the underlying layer of Flutter. Roku has rumors that they open their development to web development, but nothing is confirmed. So we're sort of a bit open how to solve this platform. And obviously more feature search is obviously important, and we'll add that in the next months. Topics, personalization, regional content, more personalization. So there's lot going to come. The app will keep us busy for at least the next 3 years. Yeah, this is it. This is the start of our journey. And just to recap, we have set up a project, we have done some analysis, we have chosen a technology, and the technology will keep us hopefully sort of not just with exciting adventures, but hopefully we'll solve some other problems that we have with sort of different platforms in-house. And we started with small steps and plan to continue that. But the first learning is that Flutter and TV works quite well after some adventures, but still. So this is what we wanted to talk about. And yeah, maybe you have questions. Now is the time, I think.